Hello there, everyone. Mike here. Just putting a video here together about analyzing graphs. Someone asked me a particular question. Where is a graph flat? Well, without doing any math at all, I can tell you a graph is just like a mountain. So, at the top. That's why you climb all the way up, so that you can get up there, see the view, enjoy the birds, not a cloud in the sky. Right at the top here. That's where the mountain is flat. And so for any curvy graph, any shape like this, that's where the graph is flat. Now to get mathematical, flat means that the slope is going to be 0. 0. Doesn't mean the slope doesn't exist. We can do that in a different session in math or in your philosophy class. Right? But for now, at the top, when you get to the top of the mountain, top of this part of a graph, the slope is 0. So let's take a look at the calculus in order to figure this out. To do so, we're going to create a quadratic equation and a parabola like you've seen in grade 11. So let's do this. Let's say we have a quadratic equation, parabola. We'll say it has zeros at x equals 0 and x equals 4. We won't say there's, if you're aware of transformations, well, there aren't any, apart from this shifting here, but no stretches or anything. So what is this equation going to look like? Well, it's going to look like this. It'll have these factors, x and x minus 4. And when you multiply this out, it will have an equation that looks like this. X squared minus 4x. If you were to graph this out, you would see that it looks something like this, with our 1, 0 there, our other 0 there at 4. And then the graph's going to look something like this. Oh, I missed it. Unbelievable. All right, definitely a parabola shape apart from that little piece. All right, but there'll be a bottom part and then the zeros there, as we said. Well, this doesn't look like a mountain at all. This looks like a valley, which this all works for, by the way, because it's flat at the bottom of a valley too. See? But we talked about a mountain. So we've got to flip this upside down so that it looks like this. Same zeros, by the way. I'm going to do it like that instead. Put that at 4. 1, 2, 3, 4. This is 0. Now we got a mountain. It's supposed to be symmetrical, by the way. So tug that part over a little bit. But our equation now looks like this. Because we flipped it over, it looks like that, which you can take on faith right now, or you can go and review the transformation section. So this is what we'll work with. And this picture too, I might add. So, as rough as it is, where is the top? Well, it's supposed to be in the middle. So it's supposed to be at an x value of 2. And then whatever y value this you get when you put 2 in here. So I put 2 in here. I get a minus 4. I put a 2 in there. I get a plus 8. So that's going to be at 4. So that's where that is. Now, constructed it ahead of time just to show you that it matches with the calculus that we're going to do. Okay, so I'm going to redraw this picture on another page. So we can see it at the same time. And 2, hopefully it's a little nicer looking as well. So there it is. Maybe that's the trick. Draw the parabola first. 3. Still at 4. Still at 0. And as we just saw, at 2 and 4 at the top. Oh yeah, and the equation is y is equal to minus x squared plus 4x. Well, the question was, where is this graph flat? We know, at the top. Okay, so let's find it. How? By using calculus. This is what you would do. Well, the first thing is that calculus isn't like grade 10. If you had an equation that looked like this, 2x plus 3, this is the equation of a line. You just point with your finger and voila, that's the slope. It's thought that automatic. Okay, but with calculus, not so much. We got to do 2 steps. With calculus, we got to do 1. We're going to find the slope equation first. Got to get the slope equation. And then once you have the slope equation, well, we want to know where the slope is 0. We want to know where the graph is flat. So flat, therefore, what that means is make the slope equation 0. Then we'll have a little bit of algebra to do. But those are the steps. And we know the answer. It's going to be at, where is it going to be flat? It's going to be flat at x is equal to 2, because that's where the top is. So here's how you do it. To get this slope equation, what you do is you take the exponent that's on the top, you multiply it by the coefficient that's in the front, and then you subtract 1 for the exponent and leave that up there. So 3 steps. Exponent goes down and multiplies. Subtract 1. Well, maybe 2 steps. I guess that's it. Leave it there. 3rd step. Alright, so doing this one, we have a minus 1 in the front. The 2 comes down, so you get a minus 2. And you subtract 1 from this value. Always subtract 1. 2 minus 1 is 1. So we'll write it in there for now. Same over here. This is the equation we're given, but understand that there's an invisible 1 up there. We just don't write it. So what's the process? Exponent comes down and multiplies. Subtract 1, leave it. So 1 times 4 creates a 4. 1 minus 1 creates a 0. And this is what you get as a middle step. And I'm going to even say T for teaching step right now, because you can jump past this once you've got the skills. Once you've got the skills. Okay, but exponent comes down, multiplies, subtract by 1, write it down. Exponent comes down, multiplies, subtract 1, write it down. Okay, so some cleanup now. So first of all, this is the slope equation. We do that work, and this is what we get. That's how you get it. Anything with an exponent of 1, yeah, we just leave it off. We've been doing that for a long time. And then going back to exponent rules, anything with an exponent of 0 is 1. So this thing turns into a 1. And that leaves 4 times 1, which of course is just 4. So if we want to find the slope for our given equation, this is the formula that we use. Now, we wanted it flat. Where is this graph flat? Where is the slope equation equal to 0? Well, look what we did. Slope equation, set it to 0. And now you have this to solve. So now 2x goes over to that side. 4, you work it out, and what do you get? You get the value that we created, that we saw ahead of time. That x is equal to 2. Okay, so the graph is, so from our work, we saw that for y is equal to minus x squared x plus 4, minus x squared plus 4x is flat. At x equals 2. All right, so that's the process for seeing where the graph is flat. Now, this is probably going to be one piece of a larger problem, but hopefully you found this step helpful, or this piece helpful, and that yeah, you can use it with your future work. Thank you for stopping by. Perhaps I'll see you again sometime. Take care and good luck.